I want to take this opportunity to address some facets of early season corn management and some of the things that we need to be working on in the coming weeks as far as assessment and decisions that we make. It's a time of year where many of us have already done all our planter maintenance and are maybe testing things or are already in the field. And so one of the things we need to recognize is the performance of those planters and how well they are singulating seed, placing seed where we want it with uniform spacing. I want to talk a little bit about variability because, again, we have, for most of us, we've already set this up, we're ready to go. But in the coming weeks, we're going to be able to assess how good a job we did, and that will allow us to make some tweaks for the coming year. So let's talk about some of the sources of variability in terms of our corn stands. If we have very crowded plants here and there, it's typically caused by a planter malfunction. It could be lots of things. Could be a problem with a meter, could be a problem with vacuum, could be simply seed bouncing around in the seed tube. But all of those things contribute to this. And it's illustrated by this plant here in red where it says, please help me. But honestly, there's way too much competition there between those neighboring plants, and that plant is going to suffer, as will as neighboring plants, and yields will not be as optimum as anywhere near optimum like they should. Variability is also characterized by gaps between plants. Those gaps are various sizes, and those can also be caused by planter malfunction or poor germination or survival of plants. Most of us have good quality hybrids that are this year's crop, and so germination typically isn't the issue unless we have some really harsh conditions. But survival of those plants is a concern, and that can be a reflection of pest predation, disease maybe in soils, depending on the time it might take to emerge. It could also be issues with planting depth or consistency, maybe worn seed openers, those kinds of things that allow us to, cause us to plant at variable depths and expose that seed to, some seeds to harsher environments. So lots of causes there in terms of a potential, but we need to understand if that's going on, then what we need to do some assessment of the planter units, planter performance, and try to understand what is happening. We also most often, I think, typically have a mixture of crowded plants and some gaps. And again, that's the same root causes. It's either planter malfunction or poor germination or survival of those plants. So we have some unknown reasons there, but we need to understand how to diagnose and get to the bottom of that so that we can improve performance. In terms of the effect of gaps on yield, there's generally, based on our research, not much effect if the final plant population is still within the optimum range. So in this slide, I say 20 to 28, and that's typical for a lot of the soils in Virginia. For some farmers, it might be a little bit higher. But if it's within that, still within that optimum range for your overall plant population goal, then gaps aren't typically that detrimental. We do see lower grain yields if the surviving plant population is significantly less than optimal. So we still need to see that stand even with the gaps. The effect of gaps plus doubles, when variable plant spacing is a mixture of both, then the effect is usually negative. So we see a decline in yield because the extra plants and the plants adjacent to the gaps can't make up for the missing plants and make up for that grain yield. So we typically see yield loss in that scenario when we have, both of our problems together. Here's some data from a few years ago generated by our friends at NC State, Ronnie Heiniger and his crew. And they used a measure called the standard deviation. So this is a calculation of how variable the stands are. And they used a number of methods to generate different standard deviations or degrees of skips and doubles and so on and so forth to illustrate this. So they have a check best here. So this is their standard deviation. This is about as good as your planter is going to do with everything set up well, driving slowly and paying attention to everything. Here's a high-speed finger pickup planter, a cone planter, which is known to be irregular, a cone planter with a setting that's even more so, and in a cone setting that is also considerably higher deviation. So we've drawn lines to this and said this is kind of like high speed, maybe 6.5, 7 miles an hour. These are single skips where the planter is malfunctioning. These are skips and doubles with this standard deviation of about 6, and then severe skips might have a standard deviation of 8 or 9. The impact of that is shown in this next slide from NC State. And I think this is sort of the useful thing, is if our standard deviations are in that 2 to 3 range, so we're 2 to 3 inches off of exactly where we want to be across the field, yields aren't impacted all that much. But if you look at the slopes of these two lines, it's pretty obvious that this upper line declined at about 5 bushels per acre for every inch increase in plant spacing variability, and this lower line by 9 bushels. So there is a 5 bushel or per acre loss here or more, depending on the location, as that variability increases. Now I want to go back and show you where we were on that, and just think about that. So that, think about where we were. We had, our standard best is around a 2. Higher speed gets you to about a 3. Single skips are getting you to a 3 and a 4, and then you start getting into skips and doubles, and you're talking about this range of 5 to 6. So you're giving up, 10 to maybe even 20 bushels over a uniform stand. So a very important, impactful management decision. And again, we're at this point in the season where a lot of this work has probably been done for many of our farmers. Some have yet to plant. But take the time over the next 2 to 3 weeks as your corn stands come up, go back and reassess those and make sure that you understand which of those plants came up and then died, which of those seeds were viable if you're seeing stands that are kind of skippy, and just understand what it is that's going on so we know how to tweak that and fix that either later this season or going forward in future seasons. And the other thing I wanted to talk about today is fertilizer placement. And this is the result of some work from about 15 years ago, but still very relevant. So this, what was done here is this is a starter fertilizer treatment placed 2 by 2, so 2 inches to the side of the seed and 2 inches below, with rates of 10, 30, 50, and 70 pounds. All other things, the crop was treated equally in all other ways. And then they compared that also to a 10-pound starter rate plus 60 pounds of nitrogen broadcast. And what I want to point out to you in terms of the efficiency of starter application is that if you look, it took about 30 pounds of starter in a 2 by 2 band to equal the same yield potential as 60 broadcast plus 10 pounds in starter. So it's almost double the efficiency simply by using that starter fertilizer and placing it in an area where those seeds can access it very readily, within a few inches. So it's a much more efficient system, especially when soils are cold, root growth is slow, and so on and so forth. So it's a system that we certainly advocate from the perspective of Virginia Tech because of this. It's a much more efficient system. We can get the same yield with half the fertilizer simply by putting it on the planter and making it positionally available to the seed rather than broadcasting it on the surface. I want to share something with you in terms of the rest of that data from those studies. So this is the optimum rate after the fact, solved after the fact, for the starter band placed 2 by 2. And you can see across all these different soil series, the right thing to do was typically a very high starter band rate. Now, we don't recommend rates that high because of the potential for salt injury. In these studies, in these years, we didn't get that because there was adequate rainfall. Yet, we're talking at the minimum about 30 pounds and at the maximum 70 pounds of starter. So my take-home message for this is that, across all these soil series, the correct thing to do in terms of starter nitrogen rate was never 0. It was always at least 30 pounds. So that tells me that almost without fail, a starter band application is absolutely the way to go. I understand, the efficiencies with planting and the time constraints and all those things, but strictly in terms of nitrogen use efficiency, this is a much better system. And it, again, across all these studies, the answer was never zero. It was always a significant amount. Now, contrast that with our side dress rates, where we range from 0 up to 125 pounds, which being the right thing to do. And the range there is indicative of our typical ranging conditions in Virginia. We have some low yielding conditions, so with 90 bushel corn, we didn't need any additional side dress. And with some of these that are 160, 150, 130, we needed more, and that's fairly typical. One of the advantages that this system with a starter band plus a side dress allows you to do is it allows you to make that decision on the appropriate appropriate side dress rate later in the season, so you know a little bit more about what's happened. Has it been, wet and warm? Has it been cool and dry? Where are we in the season? And what more do we know about yield potential than we might have before planting? With all that said, though, we do have a concern. If we look at the V6 to V8 developmental stage, so when the corn's, maybe knee-high to waist-high, all the leaves have formed, the growing point has reached the soil surface, and the number of kernel rows is being determined. So the number of rows around the ear is being set at this stage in that V6 to V8 range. Here's an example of that. Here's some corn with no nitrogen applied pre-plant, and this is side dressed at 5 weeks after emergence, and this is at 7 weeks after emergence. We missed that first critical stage of corn growth and development there, and so this corn was starved for nitrogen and has much less yield potential than the corn here on the left. And so, again, while we advocate this approach because of fertilizer efficiency and because of overall improvements in productivity, we also understand that we need to have enough fertilizer out there in the early part of the season to give us a window to get our corn side dressed. We don't want to get past that V8 stage where the corn's nearing waist high without getting that side dress on. We don't want to risk that because there's a potential for dramatic yield loss. That's what I have for you guys today. Here's my contact information. If anybody has any questions for me, I'd be happy to try to answer. Probably won't be real fast to the email through the month of April for many of the same reasons that our farmers are also very busy right now. But I'll be happy to try to answer questions as they come up and reach out to me. Thank you.